Good morning. I am here to talk on the topic the helium atom. As we all know, helium atom is composed of two electrons. Here we discuss the different method approximation for calculate the helium atom energy levels. So, inside the helium there are two electrons. So distance between the electron and the nucleus we marked here as r1 and r2, and the distance between two electron is r12. So we can write the basic Hamiltonian is given by, we know it is equal to T plus B. So here we have h square by 2m del 1 square minus z e square by r1 minus h square by 2m del 2 square minus z e square by r2 plus e square by r12. So if the last term e square by r12 were absent, then with the identity question ignored, the wave function would be just the product of two hydrogen atoms wave functions with z equal to 1 changed to z equal to 2. So we have the Schrodinger equation, that is E psi equal to H psi equal to E psi. So here minus h square by 2m del 1 square minus h square by 2m del 2 square minus z e square by r1 minus z e square by r2 into phi of r1 r2 equal to E into phi of r1 r2. Here we take phi A of r1 and phi B of r2 are the one electron wave function as in the hydrogen atom. So we can write phi of r1 r2 as phi A of r1 phi B of r2. So we can write the Schrodinger equation as minus h square by 2m del 1 square minus z e square by r1 into phi A of r1 equal to EA into phi A of r1. Like this we can write for phi B of r2. We have E equal to EA plus EB. Two electrons that we here called A and B move independently of each other, and the total energy of the system is simply sum of the energies of non-interacting particle. So we can write the phi of r1 as rn1 l1 of r1 yln m1 of theta 1 phi 1. The term ylm of theta phi we learned in our previous classes, that in addition theorem of spherical harmonics. So like this, phi b of r2 equal to rn2 l2 of r2 yl2 m2 of theta 2 phi 2. So we got the En as minus z square by n square into m e raised to 4 by 2h square, which is equal to minus z square by n square into h, where h is equal to m e raised to 4 by 2h square, which is equal to 13.605 electron volt. The ground state energy of the helium when the both electrons are in oneness level, E is equal to EA plus EB, which we can calculate as minus 108.8 electron volt. The experimental value of the ionization energy, that is the energy required to remove one electron of helium atom, is 24.63 electron volt. Then when one electron is removed, then the energy of the ionized helium is minus 54.4 electron volt. So from this value we can calculate the ground state energy of the helium, that is equal to minus 79.03 electron volt. Thus atomic energies calculated in this manner are poor approximation to the actual eigenvalue. However, the calculated energies and the wave function can be improved by introducing the interelectronic representation term VE as a perturbation. The term VE is equal to minus e square by r12 that we assumed to be absent in our first part. Considering the electron repulsion, H is equal to minus h square by 2m del 1 square minus h square by 2m del 2 square minus z e square by r1 minus z e square by r2 plus e square by r12. We will consider the first order perturbation theory. In this approximation, we take the unperturbed Hamiltonian as h naught is equal to h square by 2m del 1 square minus h square by 2m del 2 square minus z square by r1 minus z square by r2. And the perturbed Hamiltonian as a square by r12, which is denoted as h prime. So substituting h naught and h prime in the Schrodinger equation, we got h naught plus h prime into phi a of r1 phi b of r2 equal to e into phi a of r1 phi b of r2. So we are interested to calculate the ground state energy. We know that both electrons are in oneness level. So n equal to 1, L equal to 0, m equal to 0. So the ground state wave function of the hydrogen atom is phi nlm equal to phi 100, that is n equal to 1, L equal to 0, m equal to 0. So phi 100 of r equal to 1 by root 4 pi z by a naught all raised to 3 by 2 2e raised to minus z r by a naught. So for the ground state wave function for both electrons, we can write as phi of r1 and phi of r2. So for phi of r1 into phi of r2, we got as 1 by pi z by a naught all raised to 3 e raised to minus z r1 plus r2 by a naught. And evaluating the term e square by r12, which is equal to double integral phi star of r1 phi star of r2 e square by r1 minus r2 phi of r1 phi of r2 d tau 1 d tau 2 equal to z raised to 6 by pi square into e square by a naught raised to 6 into integral d tau 1 e raised to minus 2z r1 by a naught integral d tau 2 e raised to minus 2z r2 by a naught 1 by r1 minus r2. We have two values for 1 by r1 minus r2, that is when r1 greater than or equal to r2, this will become 1 by r1 summation over L r2 by r1 all raised to L PL cos theta. When r2 greater than or equal to r1, this will become 1 by r2 into summation over L r1 by r2 all raised to L PL cos theta. Theta is the angle between r1 and r2, and d tau 2 can be written as r2 squared dr2 sin theta d theta d phi. And we introduce the term rho 1, which is equal to 27 r1 by a naught, rho 2 equal to 27 r2 by a naught. So substituting all these terms and evaluating the integral, we got the term e square by r12 as phi by 8z e square by a naught, which is equal to phi z by 4 eh. Here eh is equal to e square by 2a naught equal to 13.605 electron volt. According to the first order perturbation theory, the ground state energy of the helium atom is minus 8 Eh plus 5Z by 4 Eh. This value that we got earlier and the 5Z by 4 Eh that we got for the term E square by R12, which is equal to minus 8 Eh plus 10 by 4 Eh equal to minus 108.84 plus 34.01 equal to minus 74.83 electron volt. So according to first order perturbation theory, we got the ground state energy of helium atom, and we know the experimental value of ground state energy of helium atom, which is equal to minus 79.0 electron volt. So the error is 4.2 electron volt.